Hello all, myself Mrs. Mayuri Kangale, Assistant Professor of Mathematics from the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. Today we are going to see binomial distribution. The learning outcome is, at the end of this session, the students will be able to solve the examples of binomial distribution. Binomial distribution is a discrete probability distribution which is obtained from the probability small p of the happening of an event is same in all the trials, and there are only two events in each trial. Let us see the assumptions to apply the binomial distribution. First assumption is the number of trials is fixed and finite, say small n. Each trial results in two ways: success, that is occurrence of an event, or failure, that is the non-occurrence of an event. Third assumption is the probability of success is small p and the probability of failure is considered as small q, such that p plus q is always equals to 1 and remains the same for all the trials. And the last assumption is all trials are independent. Now let us see the definition of binomial distribution. If x denote the number of successes in n trials satisfying above conditions, then the probability of r successes is given by probability of x equals to r, which is equals to NCR p raised to r q raised to n minus r, where this r is equals to 1, 2, 3 up to n. Probability of success small p lies between 0 to 1 and p plus q is always equals to 1. Here n, p, q are called as the parameters or constants of the distribution. Let us see the meaning of the definition. Here this variable x is a discrete random variable. R is the number of successes for which we want to count the probability. Here n is the number of trials and NCR is the combination of R successes from n trials, and it can be calculated by the formula NCR equals to n factorial upon n minus r factorial into r factorial, or you can calculate the value of NCR using calculator. Small p is the probability of success and small q is the probability of failure. Now let us see the properties of binomial distribution. The mean of the binomial distribution is m equal to x bar equals to np for binomial distribution. The variance of the distribution is given as v of x equals to npq, and we know that the standard deviation is square root of variance. So, we get the standard deviation equals to under root npq. Third property of the binomial distribution: if the experiment each of n trials repeated capital N times, then the expectation of r successes, that is the expected frequency of r successes in capital N experiments, is frequency equals to capital N into the probability of x equals to r, that is capital N into NCR p raised to r q raised to n minus r. The fourth property of the binomial distribution: we know that the mean, which is equals to np, and variance is equals to npq. Also we know that the value of q lies between 0 to 1. We obtain the variance by multiplying the mean by q, and this value of q is less than 1. That's why this variance will be always less than mean. Now let us see the applications of binomial distribution. We can use the binomial distribution in problem solving, tossing of a coin in which we get the two outcomes, heads or tails. The result of an examination in which we get the outcome as pass or fail, success or failure. The result of a game in which we get the outcome win or loss. The result of an inspection in which we get the outcome as acceptance or rejection. the result of an inspection of an article in which we get the outcome as defective or non-defective, etc. Now, let us see the type 1 examples. For a binomial distribution, mean is 12 and the variance is 4. Find all constants. It is given that the mean, that is x bar, is equals to 12 and the variance of x is equals to 4. For the binomial distribution, we know that mean is equals to np and variance of x is equals to npq. The mean is np and its value is given as 12. So, using this formula, we can find out the value for n, which is obtained by dividing 12 by p. Therefore, we get n equals to 12 by p and we will call it as equation number 1. And variance of x is given as npq and which is equal to 4. Therefore, substituting equation 1 in this equation npq equals to 4, we get 12 by p into pq equals to 4. This p get cancelled and we get 12q equals to 4, from which we can write q equals to 1 by 3, which is one of the constant. For the binomial distribution, p plus q is equals to 1 and q is obtained as 1 by 3. So, substituting q in p plus q equals to 1 gives us p plus 1 by 3 equals to 1, which gives us p equals to 2 upon 3. Now, we want to find out the value of n. From equation 1, we have n equals to 12 by p. Let us substitute the value of p as 2 by 3 here. So, we get n equals to 12 upon 2 by 3. Now, denominator goes to the numerator, which gives us 12 into 3 upon 2. So, we get the value of n equals to 18. Therefore, n equals to 18, p equals to 2 by 3 and q equals to 1 by 3 are the constants of given binomial distribution. Please pause the video for a minute and solve the example. I hope you all have solved the example. Let us check the solution. Here mean is given as 24 and standard deviation is 1, and we know that for a binomial distribution, mean is equals to np and standard deviation is the square root of variance, which is equals to square root of npq. Mean is given as np, so equals to 24, from which we get n equals to 24 by p, which will be called as equation 1. Variance is the standard deviation square, it is equals to 1 square equals to 1, and variance is npq, so npq is equals to 1. In this equation, we will substitute the value of n, which gives us 24 by p into pq equals to 1, p cancels and we get the value of q as 1 by 24. Substituting the value of q equals to 1 by 24 in the equation p plus q equals to 1, which gives us p equals to 23 by 24. From equation 1, n is equals to 24 by p, which gives us the value of n as 25.043. But as we know that n is the number of trials, it should be an integer. That's why rounding off this number to 25. Therefore, n equals to 25, p equals to 23 by 24 and q equals to 1 by 24 are the constants of binomial distribution. Now, let us see the third example. In a binomial distribution consisting of 5 independent trials, probabilities of 1 and 2 successes are 0.4096 and 0.2048 respectively. Find the parameter small p of the distribution. Given the 5 independent trials are there, so n is equal to 5. The probability of 1 is equals to 0.4096 and probability of x equals to 2 is given as 0.2048. And we know that for binomial distribution, probability of x equals to r is NCR p raised to r q raised to n minus r. Therefore, probability of x equals to 1, which is 0.4096, can be formulated as 5c1 p raised to 1 q raised to 5 minus 1. Here n is 5, r is 1. See here, compare this probability of x equals to 1 with probability of x equals to r. So we get the value of r as 1. So we get 5c1. P raised to r is there, so p raised to 1. Q raised to n minus r is there, so 5 minus 1. So we get 5c1, p raised to 1, q raised to 4. Similarly, we can formulate the probability of x equals to 2 with 5c2, p raised to 2, q raised to 3. Now we know that 5c1 is 5 and 5c2 is 10. So we can write 5p q raised to 4 equals to 0.4096 and 10 p square q cube equals to 0.2048. We will call these equations as equation number 2 and 3 respectively. Now to find out the value of p, we will divide the equation 3 by equation number 2. So we can write 10 p square q cube upon 5 p q raised to 4 equals to 0.2048 upon 0.4096, which gives us the equation as 2p upon q equals to 1 by 2, from which we can get the equation as p equals to 1 by 4q. As we know that p plus q equals to 1, q equals to 1 minus p. So substituting this q equals to 1 minus p in this equation, p equals to 1 by 4q. We get 1 by 4 into the bracket 1 minus p, which can be written as p equals to 1 by 4 minus 1 by 4p. Shifting this minus 1 by 4p on left side gives us p plus 1 by 4p equal to 1 by 4. So we get p equals to 1 by 4 into this 5 by 4 shifted to right side gives us 4 upon 5. So 1 by 4 into 4 upon 5. 4 get cancelled and we get p equals to 1 upon 5, which is nothing but 0.2. Therefore, p is equals to 0.2. Thank you.